Okay, we start recording again. Good. Let me start sharing my screen. Okay, we're recording, we're sharing. Good. So this one is Kyle's. Make sure Kyle is here. Yes, you are. Good. So let's take a look here. You have the rainbow. You have 3 questions here. Let's see, drainage area. FP6 is much larger than it needs to be. Well, so in this case, you could divide them into 2 because you can see that from high to end, you slice them into half. There will be some elevation changes where basically you would have slightly different elevations for the 2 cells. Annotate here. Like this.
So, Wuhong.
Hey, yeah.
So, what I meant by that was like the retention area is much bigger than it needs to be. So, in the
okay.
spreadsheet, do I say the actual size that it, like the minimum size it has to be, or should I just resize it so that the numbers match?
Don't resize it.
Okay.
You would enter the area necessary, and you
Okay.
could. Why do I? Yeah, I hear students' voice. Anyway, yeah, you would enter the area necessary for the drainage area, and you could
Okay.
also add another column of actual size. So then,
Uh,
yeah, that would be very clear that you have an oversized retention here, basically leaving additional capacity. You could even have your some of the roof drain to there if you want to.
okay.
Yes, that's
All right. Thank you.
the contours here. Well, could be. I would actually turn that and then follow this. So you can kind of see these are more uniformly, possibly 2%, instead of having this portion being more steep than this area. That makes sense? The contours here?
Yep.
Yeah, so this will be your this portion of the center line or ridge
Okay.
line, and those 2 red lines are your new contours. Okay, so moving down here. Any suggestions for separating the roof? Can the whole thing be a green roof, or should we separate into segments? You would definitely have to separate it into segments. So the way that you divide, if it's the roof, the shape of the roof would be determined by you, um, by the building design. It could be sloped or it could be flat ones, but you would imagine that you would at least have 2 downspouts, or if not more. And honestly, I would calculate the roof area and see how big it is and divide it by 5,000 square feet and see how many downspouts at least that you would need to have, right? So it's likely going to be the downspout, usually it's at the end of the wall. If we need more, you could even do this, and then you could have scuppers or trench drains coming down that would connect to wherever you design. Oh, that's not what I want. Connect to wherever you want to design the destination to be. right? So if you think, oh, that's not a really great area, we can get rid of that one and say, no, that's where water comes off from this, the left portion of the roof. But yes, you need to divide them into smaller areas and specify the destination of each subdivision. Do we have to divide the ramp into drainage? No, the ramp could be basically the ramp will the runoff will not be collected from that ramp, would not be concentrated because it's surrounded by vegetation and it's perfectly fine for it to disperse into the surrounding vegetated areas. So nope, you don't need to divide that one. Um, okay, those are all the questions. Anything else?
I think that's it. Thank you.
Okay, cool. Thank you. Moving forward. Okay, so we do, let's see, 26 actually. Ah, my computer is getting slow too. Weird. Should not have been. I'm trying to close down some of the things. It's really strange. All right. Okay, we have 26. Couple of, this is errands. Couple of questions here. Should MP be split with the section run through the curb onto the... The building be a single section? I think we addressed that just now. MP section run through the curb onto the plaza. Let me zoom into so that I can see what is M and what is P. Yeah, these files must be a little big. Usually it's not as slow as this. Come on. Oh, so yes, your M and P are at different elevations, right? So that they definitely belong to different drainage areas. What? Okay, now it's cooperating. Okay, so what I would do in your case would I would exhaust the capacity of your green area in the middle, right? So basically, no, if we have a curb cut somewhere here, no, this is all the area that you'll be able to treat. Well, we do need to consider that portion. So let me clear that one and restart with this. So all that will go into your middle turnaround area. And everything else would be split into two. Now you can see both your L and your M will be smaller than before. The difficulty is actually your curb. Your curb is in fact here. So your P would not have a portion that is down the curb. Okay? So we will have to see how big this is and how well the purple or the pink here, I see that is actually reasonably directed into this area. So that is solved. But I do see that we are having difficulty, not having difficulty, but yes, this is a bigger area that will need to verify how big this is and see if it's exceed 5,000 square feet. And if so, yeah, honestly, we don't have a great way of dealing with that except for cutting it off, if that's bigger than 5,000 feet, you would cut some holes here. That's not a good color. Let me change to, you cut some holes here. So then you can divide that into two by doing this. Does that make sense?
Yeah, but could I cut a hole right there because that's where the bus drop off is, and like it really wouldn't make sense to me at least.
So um, the hole can also be somewhere here. Or you could reduce your plaza area, um, leaving a path to the stairs, but remove some of the pavement here. Otherwise, everything would indeed drain to the bottom somewhere. This is the lowest location. The lowest location along this curb is somewhere here. And then water has to be directed from this point either to the vegetated area over here or to some sort of a depression in the plaza area. Does that make sense? Because it's hard for you to, what I'm trying to say is define where exactly people get off and how that relates to your entrance of the building. And the plaza, well, the drop off area, you drive in and you kind of circle around, go out, right? If the entrance is over here, it makes sense to have the drop off area somewhere like this. No, people would see that and get in there. So the area that you need for people to get off may be that curb. So you don't need the whole area to be open for people to get off. Does that make sense? And then the pavement in this area can be reduced, but you do need to think about how do I connect back to the stair here and the ramp. So my thinking is that this triangular area could be reduced. Okay, so that's that portion. I see two questions. Anywhere else where I should look for one more?
Yeah, I had one up here in the top, by like A, by B there. It was just
Oh,
about
yes, yes,
if it
I
could
see that
be
one.
below 1,000 square feet.
That should be okay.
Okay, thank
So
you.
that's a smaller one. Let's zoom in, take a closer look just to make sure. Oh, yeah, that's a smaller one. No problem. That'd be okay. So that's a ridge line. That's lowest point. Yeah, you would have an opening there anyways. Somewhere, actually, somewhere here would have a opening at the tip of that triangle. That'd be okay. All right, so that's this one. Good to move forward?
Yeah, thank you very much.
Oh, you're welcome. All right, we have 126. Let me see. I need to know the name.
Yeah, I don't know why my questions aren't showing up.
And is it 27 here? Mm,
I could just tell you
well,
the
yeah,
questions I
yeah.
have.
Let me know which area you want me to zoom into and check.
Well, I first wanted to ask if it was okay that the drainage areas were up top for, I think it was like N, O,
And
and P.
let's see. Over here, the N.
Yeah, because I didn't know you can combine the drainage areas, so I was running out of room at the bottom.
Given that right now your drainage areas are about 1,000 square feet, you could combine them. You could combine them, and um, But one question I do have is we're not utilizing the green areas that much at this point, right? So our green area is over here, and this green area would be able to accept water of that much. And I'm trying to see, no, there's no ridge line over here. So it's pretty much that area that is able to be treated by this green area. And that helps you a lot in terms of um, reducing NM. So not all of them would go down here, right? And the other thing is you have this green area here. Yeah, let me use a green instead. That's not very big, but still, no, every little bit would help. So you actually have all this going into the screen here. You would want to verify if that green is big enough for that area. If not, then that green needs to be break down into further the smaller areas. The O and N, they don't really make sense because N and O are upstream, right? So O actually needs to go down. So these needs to be go down in this area. So anything that is not covered by the green and the red that I just drew is actually going to the bottom. Yeah.
I also had a question on my plaza, like if it works.
The plaza, yeah, the plaza would be, according to what Stuart just reviewed, anything, if you do not cut holes here, everything would actually be draining along the plaza drainage way down into your, so all the I would actually be draining into your turnaround area here. So now when we think about, no, we're not designing the contour, we're not dropping the parking lot yet, but the curb needs to be considered when we delineate these areas, right? So the I with the curb is actually all going to, most of them is going to drain into the ridge line, not the, so the swale. So sorry, the swale inside of the drain, the turnaround, and your swale line is over here. So R actually also would drain into your parking lot somewhere here if you don't cut holes. Cutting holes is one way of reducing that drainage area that will actually eventually go down your turnaround. So because we don't have much green dedicated right now, I would actually think adding more is necessary because now your green, your purple, your pink, and your purple, they're all paved and they all needs to be treated somewhere, and it should not be, it should not all be there.
Yeah, can I use a trench drain to bring the water out?
Yes,
So
yes,
how would
yes,
it
you
look in my
could.
plaza?
Right. Yeah. If you want I to be going into your eye, small eye there, you would use a trench drain because everything is eventually draining down here, right? Bad color choice. It's going to drain before it falls into your turnaround area. If it can be collected by something like that, you could have a trench drain. Well, yeah, in fact, the trench drain, if you want to collect all of them, it needs to be, all of these needs to have the trench drain, and then that could be directed into that small eye. So that's a way too. But the central thing I think is that most of your small letter bioretention are upstream of your actual paved area, so they need to be moved to the downstream area here. Okay. Yeah, these needs to be moved downstream too. Those make sense. Those are okay. Those are okay. So 2 suggestions. Yes, trench drain. The other one, think about where you could reduce the pavement and then move the bioretention to the downstream side of your contributing areas.
All right, so that trench drain would just go along the curb line, right? By my turnaround. That's what you drew.
You need that side too. Does that make sense?
Oh,
Because
okay.
all
So
the water is draining down
yeah,
here, right?
I see.
Otherwise, it will be dispersed. Well, dispersing it's okay too. So, okay, if you want to collect everything into the cell, you need that to circle around the pavement area. If you design for this to flow, for this side to flow directly to the vegetated area and only collect some of them, then you could put a trench drain. In fact, if you put a trench drain this direction, you would be able to collect most of these areas into your small eye. If it's along the curb, you're only able to collect this much. If it's this side and here, you would be able to collect this much. Okay, and there are small slivers that wouldn't be able to collect it. That's okay. So the principle of deciding how much area in D that you would be able to collect is the exact same thing as when you come up, divide these pavement area, right? If I have something that is, drawn like that, if I only have, just one more time, demonstrate how we decide that. If I only have that portion, this is how much I can collect. Extending that to the ridge line, this is how much I can collect. Okay, and if I don't have the trench drain over here, then this portion wouldn't be able to be collected. They will just keep flowing downstream. Hope that helps. Okay. Okay. Does that answer all your questions?
Yeah. Thank you.
Okay. You're welcome. All right. Let me move forward here. Yeah, these will have to go to the cat room. Can F and G drain into the same retention? F and G. They could. Well, let's think about how we direct F, right? If we want F to drain into this green area, we will have to cut through that pavement. Then let's think about whether or not that pavement is necessary. We talked about before how this detail of a curve and a straight line creating an accurate angle in terms of construction is very hard. Treating of the detail would also be pretty difficult, and honestly, that little pavement area, you won't be able to stand on that, so it's not functional either. So in this case, you could actually start thinking if that pavement can be modified to be perpendicular to my curve. If that's the case, you actually have a pretty good chance of collecting both the F and G into a green area on the side. Okay, so the curb cut is very easy to create from this point to that, and G, the contours are in this direction, so yes, you'll need a trench drain of some sort to collect water if you want that to be a concentrated um, flow into that retention. The slope here, if it's 1 to 4, that makes sense because you don't want you would want to reduce the sheet flow off the plaza to your vegetated area, right? But I think G is pretty small, so doesn't feel is a huge problem there. Okay, so that's that one. Does the back plaza need a retention? You could design retention there, especially when the back side, if you make it 1 to 3 or 1 to 4 slope, it could benefit from having a retention. But because most of this is vegetated area, I think, well, let me go back. The requirement. The requirement of the assignment is for you to find a way to treat all of the impervious areas. So yes, let's do a retention for the back plaza. Okay. Now in reality, you might be able to create a flatter area here so that it could be dispersed into the vegetated area. But for the purpose of the course, yes, let's create retention for the back plaza. Okay, those are the 3 questions. This is by, let's see. Is this Ryan's?
Yeah, this is mine.
Yeah. Do you have any other questions here?
No, that you covered it all. Thank you.
Okay, so these look okay. Yeah, I would modify the little circle here. I would recommend in your final submission making it more clear about where the pavement boundary is, so the TAs will be able to see a little bit more clear the kind of the distinguish a little bit better between your contours and your pavement lines. So right now contours are red.
Yeah, I couldn't get it to plot for some reason. All my colors were turning black and white. So once I figured that out, it'll show a lot better.
Right, and the other thing is you have a pretty big opening here. I would look into how to take better advantage of these areas, right? So that small area could be going into the green here. The plaza would actually, yeah, most of that water is actually going into the swale. So I'm trying to figure out where the swale is. So yeah, I need to see.
It's like right in between. Yeah, like right there.
And then there is something here, right? And I'm trying to. So these are the contours here, like that.
Yeah. Yep.
Okay. So in that case, you have most of your water actually draining into your H. So I would spend time looking into every one of my green area and see how much of these G and H is actually getting into. Feels like that much is getting into your H, at least. Not a lot. So I would probably move that to the swale. You know, if you move your green area to the middle, crosses the swale, you would have most of the pavement area on the upper side here draining into the green. Okay.
Okay.
So this green area is too it's too upstream. it is not helping that much. But if you move it downstream along your swell center line, it would help a lot. Okay. Clear here. Keep moving. This will be Adams. Oh, no, Haley's. Don't see questions. Haley, do you want to unmute and talk about the questions here?
Yeah, sorry. I guess I submitted mine without my questions. But one of the questions I had was on the plaza. My
Yes. Yeah.
my little section that's like up against the building. I guess I'm just kind of confused about how I would drain those. And I know that especially in the beginning, like Stuart was talking about making like one big block, but I think mine is just like angled awkwardly.
Not exactly. It right now it's mostly you further divided them, but in fact they actually go to the same place, right? So this I remember Stuart talked about this. So that whole thing is actually joining into the same place. And some of the design here needs to change because your center line is going right to the corner, basically meaning you have a lot of water in front of your stairs. So later on, when you revise the contours, the water needs to turn water needs to turn more to this direction, and that's not too hard to do. Let's see. That might require you to, well, actually the simplest solution is actually to turn your building a tad. Well, again, exercise 3 does not require you to make those changes, but that would be necessary, and I would not, at this point, I would not ask you to go back and turn all of your contours. But I think turning either your contours and your building would be necessary because we clearly see that the water is going to the stairs there. Okay, so the key issue with exercise 3 here is these are actually 1. That's 1, and you could subdivide that if it's too big by cutting holes or putting trench drains inside of your plaza. So that's and that's necessary, I would say, for the lower plaza here. Not exactly necessary for the upper part because your upper part here, it's pretty small. So I think that'll be okay. Now, I'm having a little difficulty understanding this area. So I can see that this portion will go to the middle, and this portion, yes, it will also go into the middle. Yeah, the key issue is the same with your plaza. Because everything here drains into your swale, right? So your light blue and your light green actually they're the same. They actually belong to the same. So all that is draining into your middle area.
Okay, and then so the other 2 blocks that I have there too, would they also become 1?
The other 2, you could split them into 2. I can see that could happen. They are at the same elevation, but having a little bit of division would actually avoid some mixing of the water, which could be beneficial. I would calculate how big this darker blue is and darker green is. If both of them adding together, it's not too big, then we combine them. If they're too big, then it could make sense. It would make sense to split into two. The key, well, if this is too big, this looks like it's going to be too big. We could split them like this, basically saying there could be inside of the facility there would be a check dam of some sort. Okay, so well, you don't need to indicate that, but this will help having the upper portion be in the first cell and then the lower portion be in the second cell. Now I might even put it in the middle. Yes, so that will avoid for the first one to be too small. Let me clear that one. So I would split it like this, and then that would be the upper, or actually downstream. That's the downstream portion. And then the other upper stream portion would go into the cell here. And there would be elevation differences between this one and that one, with a dam for separating them. So that needs to be revised. It looks like, yeah, definitely it was over 5,000 square feet before. Otherwise, okay, that looks good.
I do have one more.
Good. Yeah, go ahead.
It's about like my car turnaround where it meets the plaza. I was really unsure what to do about that like light purple block there. It's this one? The one right next to it, like in the very middle of the car turnaround. Yeah.
Here? Oh, this looks good. You basically are having a green small island here, right? No.
The one like right next, like that touches the plaza. Sorry, I really did a horrible job of choosing colors. The one right underneath it.
Right under.
Where my drain inlet is. It meets the corner of the plaza.
Here? DI?
Yes.
Oh,
yep.
Okay, that one. This is the boundary. Let's see. Is this the boundary of your plaza?
Yes.
Nope. How do people get up then? We need space to stand. Yeah, okay. Well, in terms of the design here, I would straighten up a portion of this, so the car will be parked here, or if you want people to get off here, then there would be a straighter portion. Well, that's actually no, I don't think that's a good design. So straighten up a portion of this curve to indicate clearly people are getting off here. Then I would extend part of the pavement to be sort of like that. And this portion now can be where people get off. Then here I am also, because this is quite straight, my impression was this was where people get off. But maybe that is where people get off. If that's the case, I would do the pavement like this. So so that would be the boundary of your plaza. And then that needs to go, well, it could be like this, but probably do something like that. Yeah, that's a little better. Now you have much of this in green. That's a good move, because a lot of the water is actually draining to this area, as you indicated with these like purple pink squares, right? Now, if that's the case, inevitably, the lowest point in this area is here. That's your lowest point. So you would have to have a DI. And then that DI have to be piped, which is okay. Okay? The DI will be piped over there, or it could be piped over here, depending on so this will be at the roughly the same elevation. That will be a little bit lower elevation. It will be a little easier for you to pipe it down here because this area is lower than the DI elevation, and that area is likely about the same as your DI elevation. Well, it could be, oh, it could be lower too, because your DI is at this elevation, so this will be a little bit lower too. So I would say about the same difficulty of piping it to where you have it now versus to the area over here. So you have two options there. But yes, you would need a pipe.
Okay, thank you. That makes way
Yep.
more sense.
Yeah, yeah. Okay. Yeah, some of these areas I would recommend adding a trench drain because you can see we're creating pretty long flow path. Or you could tilt your just a tad more. Then it would tend to the water would tend to be directed to the side where you have more space. You can see no, the long path would actually concentrate your flow entrance in this manner, and I think at least these two clustered together, no, oftentimes wouldn't make a lot of sense, and you probably would run out of space for that one, and because there would be a need for you to extend are these squares the correct size?
I did not make them to scale yet, no.
Okay, so that's why I'm saying these two are fairly close together. So there could be, there could be an issue of running out of space here. But I think if you tilt the contours a bit more, then you would have relatively you would shift the bioretention areas to the lower west. Then the space issue will be mitigated a little bit.
Okay, do you think that that would help with like my building rotation too? Because in my head it does. Like how you're talking about having to rotate my building in my
Right.
plaza earlier.
Your building would be rotated some way like this. So then you would avoid for, oh, do you mean instead of rotating your building, you would rotate all of your contours?
Yeah.
Well, actually that's a good previously we are having your previous center line actually looked a little suspicious to me. So let me clear my drawing and let's zoom in. Yeah, the angle, well, you can verify this. I'm not sure this angle equals to that one. It feels to me this one is larger than that. So, in fact, if you keep your, yeah,
I think all the angles are the same.
then it might be the drafting. Is a drafting issue?
Yeah.
Well, Okay, so this was not created. Okay, this was not created in AutoCAD. That might be the reason. If this angle equals to that angle, then you don't, I think systematically rotate your contour would be a good idea to have your swell away from your building. If this angle is not the same, I honestly think just by rotating this set of contours would achieve that purpose of tilting or direct more water or direct water more efficiently to a curb. Then you could rotate your building. I would first verify, I would first verify these angles here, and you can actually see that if they're not the same, rotating a tad is not it doesn't really affect your contour design that much at all. And rotating your building,
Yeah, that should be a simple thing.
Yes, rotating your building would also not be a huge cost. There wouldn't be a huge redo of your previous work. Okay, so yeah, anything else here?
Nope, those are all the questions I had. Cool. Thank you.
Awesome. Moving forward. Now we have, I think this is Adams.
Yeah, this is me.
Yeah. Question here you want to start with? You could also type if you get a lot of echoes.
Sorry, I just realized I was unmuted. I was attempting to combine some of the subsections with the color coding. I wasn't sure if that was allowed through the parking lot median there. But I checked and it was within like the square footage allotment.
You could definitely, first, I do recognize some of them are not correct yet, because your ridge line is over here, and then there's a ridge line over there. So these so the pink here, right? The this color here would not cross that ridge line, right?
Okay, yeah, I just realized I totally forgot about the ridge line.
Right, and then if I look separately at the vegetated area, I would say all these would be able to be flow into the green area. That would go into here, right? And then also that area would all go into this one, right? So these two could actually be one. They look pretty small. And if I look at green area over here, I would say, yeah, I tend to start with the green. So for instance, that whole thing here would be flowing into your green. There. These are pretty small ones. Oh, that's too thick. I go from here, move that little tad. That small sliver will go into the green as well. So I start with things around the green area, and then those can be deducted from other bigger areas, and I know the rest will go down to the bottom here, and then I can start dividing them, right? So
yeah, that
look
makes
at
a
your,
lot
yeah,
more
look at
sense.
your ridge line first. Look at your ridge line first, and then look at how big of an area that your green area would be able to service.
Yeah.
Yeah.
Okay. Yeah, that makes a lot more sense.
And that's divided into 2. That's okay. If these apple greens are too big, you could enlarge your this one.
Okay.
Right. And then we do need to find places for the plaza. And we talked a few ways of doing that, cutting holes, putting trench drains. But if they are not intersected, is actually going into your drop off. Both drop offs will receive some water from the plaza. So that needs to be, no, in order to do that, some of the designs will need to be adjusted. Okay. All right. Looks good. Right. So I want to remind that these areas, you specified the color to be here, but we also need to think about how, well, that one goes here, I know. We also need to think about what do we do with this darker blue, right? The darker blue, the lowest point, so for this, all this water, if we don't treat them, all the water will be flowing here. And that's where we need to find a way for that water to be piped out if this is still paved. I don't see a necessity for this area to be paved, in honesty, right? We're walking, yeah, we're walking from here to my, oh, that's not what I want. You find where people are walking from here. Looks like people are walking from this drop-off area to there, and people needs to walk to your ramp in this area. Now it doesn't have to be paved. Then you would have a designated area for your darker blue and even your purple here. Okay. Yeah, so working on this actually also help you understand where you don't have space, and try to adjust your design to create that green space.
Yeah.
Okay.
Okay.
Cool. I'll move forward then.
All right. Thank you.
You're welcome. 33. This will be Charlie's. Sorry. Chuck. I'm sorry.
That's okay.
Can always remember how you prefer to be addressed. Okay. There were 2 spots I couldn't fill in with hatching. Not sure why. Is this cat related or yes? I would try to skip them. Okay, this is cat related. So that would go to the cat room. Now, in terms of the content of this, I think we have a common issue where your darker yellow and lighter yellow would be combined because their destination is essentially the same. I would also emphasize looking into more how your green could be maximized by having curb cuts on the edge, right? How big of an area it could actually service. My difficulty here is actually reading the contour lines and distinguish the pavement line, where exactly the boundaries are. I can sort of see the boundary being here, and the boundary, the pavement boundary being here. I think there is a common issue where I do know, okay, the dark orange needs to go somewhere, but how does that water get out of the pavement area is an issue, right? And whether or not we should keep all that pavement area or reduce some of them to actually find a place for the yellow and green or orange here. If you have any opportunity to put some green in the middle, it actually would help quite a bit.
Okay. Yeah, I guess I was kind of confused when I was going through it. I was just kind of just putting the drainage I guess shapes on the parking lot at first, like only inside the parking lot. I guess I didn't really consider it going out onto the plaza.
Yeah, I can read and understand, the logic here. They all make sense. That doesn't. No, this line doesn't because you won't have a boundary that it will be parallel to, well, unless you put a trench drain there. Otherwise, you would not have a division line parallel to your contours. And honestly, I don't think you need to because you have much of the green here. Okay, you have much of the green in this area that could serve that area. Um, for instance, if you divide this by, that definitely would go into your green in the middle here. And then all the rest will keep flowing. I don't think that would exceed 5,000 square feet. So your this lighter red can be combined with this darker red. So they all go here and keep moving forward. Well, you could even make the division over here. So basically, you would have a curb cut somewhere here, right? So your light red would be the entire area of this. Let me change another color. That would be the second. If you do not want this to be a long route, you could even, let's move that one to, this one is the first one, no, second one, and this one is the second one. Well, doesn't really make a lot, no, in terms of design, really they're about the same. So either way would be fine. Now your driveway, it's all treated, and then we keep moving forward and see, okay, so this green area will be able to treat all that, this whole thing. If this is the all the driving area, all these actually drain into the green. Then you verify whether or not that's enough, right? That's enough area. If not, then sometimes you kind of have to deal with that because you don't really have enough space and allow some of the water to keep flowing down. But now you could see, the rest is this one. So that will be the last sliver that you would have. Does that make sense? If you go through your green area first and make sure every single square feet of your paved space is counted for, and being able to find a place for all the subdivisions, then that's sort of the purpose of this one, and say demonstrating we're able to treat all the water coming from all the areas, paved areas.
Yeah, that makes sense. Thanks.
Okay.
Just on like a general note, I guess when I was making these, I didn't really understand, or maybe I missed it in the lecture, that the black lines that like outline the colored shapes, they represent like the direction the water goes. I guess that makes sense because you're going perpendicular to the contours, but I guess I was just confused on how you make those shapes, but now that makes more sense. Thanks.
Yeah. Cool. All right, I'm gonna move forward then. Okay, we have Haley here. So does the size of the bioretention area look correct? I'm not sure what you're trying to, well, if you have calculated the yellow, the big yellow, and correspondingly calculated the small yellow, and the only thing that you need to do is to use a polygon of some sort to demonstrate I can fit that bioretention in the area. So I think the way that you represented the small kind of the bioretention areas make sense, right? Now you can kind of see, oh, I'm actually running out of space. That's actually a good finding. That's the purpose of the exercise, for you to discover where are the problem areas. Okay, so I don't know if that answers your question. If not, please let us know. Are these okay to be up here? That's all right. Those are okay. Nope. The pink, you would not have the small pink to be upstream of your contributing area. That needs to be the bottom, right? Water flows, water in this contributing area flow downstream, and we have to find a way for that to be directed out to some area in your non-paved space to get that treated. Okay, so that's one thing we talked about a couple of assignment ago. The second thing that I noticed here, these lines would be not overlap with your contour. Okay. Oh. So water will keep flowing down, and then it runs into a curb and runs into the curb, right? Well, the lowest point you would find, if we extend those lines, lowest point would be here, meaning the pink area, all the water will flow eventually down to a point of the where that's lowest, and then you have to find a way for that water to be piped out. If there's no vegetated area that's easily connectable by a curb cut, right? So I think the major issue with these are they are pretty long flow path. If you can have some green, that would be good. Your green areas in the parking lot right now seems a bit small. If you can find some potential for that to be enlarged, that'll be good. And I honestly can see some potential. I don't know the dimension of this area yet, but it looks like this could become a small island, some over here. While if it's pretty small, then it doesn't have a lot of capacity. That's okay. By shrinking some of your parking lot, if you can get a median of some sort in this area, that would also be helpful. Okay. The other thing, well, tilting your parking lot contours doesn't really help that much. If not tilting, well, the example is if I tilt a lot, you could kind of see I'm not utilizing this area to be the final destination of all the water, right? Because water you will be able to collect some water from this curb, so that tends to spread things out instead of having. I'm just giving an example. I'm not asking you to tilt your parking lot contours so that it will all, well, not always hit. So not all the drainage area will be leading to the bottom of the drop off. The issue with having all the water drain here is people. This is actually where cars would park, right? You could expect the water to be concentrated somewhere here during a big event. Having this area being the lowest has that problem. Again, I'm not asking you to radically change your design. I'm pointing out some of the issues with this design, and hopefully we can try to avoid some of these early on by having a more tilted set of contours that direct water to the side a little bit more. What I can see you doing here with this would actually be putting trench drains along the way here. So wherever this curb hits vegetated area, it has an opportunity to pipe water out. So that's what I would recommend for this one.
So when you put trench drains along the curb, do you need a bioretention area for like those
Yes.
sections as well? Okay.
You need to pipe that water out. and because the lowest point is actually here, yeah, it seems it will be very hard for you to separate the yellow, for instance, with the pink, because they travel to the lowest point there anyway. Let's see. How do we deal with this? Yeah, this is a little tough.
I think I
What's
probably just need to change the direction of my contours to separate them a little bit.
What's the area here? What's the pink area? Have you?
I have my chart. I don't know if you.
So this is 1,000. If that's 1,000, then combining them would be okay.
I don't think it's 1,000. I have my. I should have my chart submitted as well.
Okay, so let's just quickly check. I know we're running out of time, but very quickly check the pink here. It's about 3,000. Well, then that's a little hard. That would be a little challenging to break it down. Give me a second to think here. Okay, I think our first thing would be to try to add islands. That would actually help a lot. And then try to reduce some of the pavement in this area. Try to reduce some of the pavement beyond the drop-off area. Basically, the drop-off area, the necessary pavement is over here. So then you would have a opportunity to pipe water out from here and from there. And then the middle of the ones, pipe water out through a curb cut. And then the middle of the ones would be, you have to have a pipe, because it's really hard for, no, you wouldn't be able to do a curb cut over here. Even if it's a trench drain, it will be really long to direct somewhere else. So I think cutting down the pavement on the sides would be a good way to do it. And then having a pipe, a DI over here is acceptable. So those are the few things that I would suggest doing without for substantially kind of redesign your contours. Okay.
Okay, yeah, thank you. That makes sense.
If I zoom out again, if there's other problems that would actually suggest that turning everything or rotating everything would be a better design, then I would probably go that route. But I don't see that happening. Yeah, I don't see the necessity to change and rotate everything there. Okay, so though I would suggest the same things: adding green in and cutting off pavement out on the plaza. Okay, I'll move forward then. So this would be this will be Marcella's. I'm sorry, it took me a while to find the folder. Okay, now, the major issue here is some of them are not perpendicular. The dividing line is not perpendicular to the contour. All right. So for instance, your first division would look like that if I have a curb cut somewhere here. If my curb cut is over here, that's my first division. Okay. And if my curb cuts no, if I have a curb cut over here, then my second division would be something like that. Actually going to the ridge line. That's my second one. We have a pretty thin medium, and the medium doesn't seem like it could accept water, which is okay, because you don't really have a lot of water going down. Now, if I outline my ridge line here, you don't have a lot of water going into the medium, so I'm not too concerned about that. Yeah, but I think there is a there's a misunderstanding about how those lines should be drawn. It's basically they need to be perpendicular to the contour. You need to consider the swell, and you need to consider the ridge line there. So, Marcella, I know this is quite general. Do you think that would be sufficient for you to move forward?
Yeah, I think I was struggling with the perpendicular because like I would turn on the snaps in AutoCAD and it would end up looking like that. So I guess that's why I thought it looked right.
Okay.
But does like the patio, not the patio, like the front patio area look somewhat right?
The front plaza would not be divided by these because there's a swale. So essentially, all the pavement area, the only division line is actually the ridge line. So all these, if we don't cut it out, we don't put trench drains, they actually have a single destination, which is here. Let me use a red here. This is where all the water will drain to if we don't cut holes in the plaza, right? Everything in the curb would not, because there's a curb here, so it doesn't, the curb will be the barrier where water from the parking lot will not flow onto the plaza. But all these, the black line that I drew just now, will flow to the lowest point here. Well, of course, some of the water will flow off this edge. Some of that will flow off this edge. But mostly it's going to go to the edge of the plaza there. Does that make sense? So to divide this up, you have to put in either trench drains or cut a hole.
I'm kind of like confused about the trench drains. Like I know, like we've been going over it for a lot of them, but I'm like still confused on like where to put them or like how they should look.
So if we cut a hole like what I drew, just like this, if we think about what's the area that drains there, this is the boundary of back here. This is how much water will drain into that hole. All these will drain into that hole, right? Does that make sense?
Yeah, that makes sense.
Yeah. Yes. So that's one way of doing this. Let me erase that. If I put one section of this, if this is a trench drain, okay, then all this water will be able to flow into the trench drain, meaning my drainage area is that. Okay, does that make sense? So if you put a trench drain in, it will be either at the edge of the pavement or it would be parallel to the contour. If I put a trench drain perpendicular to the contour, nothing will be collected because water, well, there was only the width of the trench drain, that much water will be collected because all water will basically flow like this, won't be collecting anything. So your trench drain will be parallel to the contour or it will be at the edge. All right. The basic way of identifying how much water is collecting is to go from the edge to from the end, two ends of the trench drain, and go perpendicular to the contour. Then you know, okay, this much area is collected by that one.
Okay, I think that makes sense. So then for the other part of the plaza, it would be the same.
Yes, you would use that same principle of deciding where I would cut holes, or where I would put a drain, where I would actually let water, basically flow down. Some of these areas would actually just flow into this vegetated area. Do I want that to happen, or does that actually make it? You don't need a lot of. If I have a bioretention over here, you can actually see that much of this water will flow naturally into that area. That makes sense? So your design here is actually setting up that pretty well. You have a very flat area at the end of your swale. So you don't really need to, well, I would say you don't really need to have make a lot of efforts to try to find a way to collect that water. What I would say is, yes, let's try to divide the upper part a little bit more. So otherwise, it would be all the whole thing. The whole thing here. Some of them. The whole thing here. Not. If I don't do anything, all of these will get into that area. So I would say focus on dividing the upper part up and only have the lower portion drain into this specified bioretention area down here. Does that make sense? Yeah, I would actually think for this one, cutting a hole somewhere here is not a bad idea.
Sorry, and would the hole be like just another bioretention area?
Yes, yeah.
Okay, that makes sense. Thank you.
Okay, cool. All right, we have one more, and I'll move forward with that one. So this will be Jacob's. Sorry, Jacob, for asking you to wait this long. The purpose of the color coding is simply to distinguish. Yes, the purpose of color is simply to distinguish different drainage areas and make a connection between the contributing area and the bioretention area. All right. So is this correctly done at the start? That's pretty good. Looks pretty good here. And done correctly at the end. Not necessarily. We're not utilizing this much yet. So at the minimal, I would cut this out. Cut this portion out. And this would be a different one. Okay, this will be a different one. I'm not sure the contours here are correct yet. The contours, these contours are not correct, unfortunately. These ones, yeah. Those ones need to be changed later on. You would connect to the retaining walls away from, you won't be able to turn back into your drop off. The connection would be outside on the vegetated area there. So other than that, this looks good. This portion looks good. Now if we move forward to the bottom here, stormwater drainage, yes, you do need the plaza area. It's hard for me to see the plaza boundary lines. So right now everything is it's at the parking lot level, under the curb, So yes, we need to work on the plaza a bit more. So you don't have to change the contours accounting for the curb to be able to delineate the plaza. All right. Nope, don't drop your parking lot yet. Basically, take into consideration of the drainage pattern on top of the plaza, right? Essentially they just drain, using the ridge line as a divide line. Half of the plaza drain this direction, half the plaza drain into your drop-off area, and here you probably don't have a way to work around that, which is okay. Basically meaning that these walking areas and part of the plaza will drain into your drop-off. I don't see. You could choose to put a trench drain. You could choose to divide some of these paved areas up, but honestly, because it's pretty small, I think it's okay not to do that and let it run onto your drop-off area would be acceptable. And here you have the flatter area in this area and along the swale. So all of your plaza would actually drain into this vegetated area. I think the matter here is to decide where you want your plaza boundary to be. Okay, is it the boundary to be here? Somewhere I don't need arrows. The boundary here or there, or where's your stairs, or no, it seems like you have something of a ramp over here. So the design of the ramp here would honestly, well, the plaza boundary would help you decide if you need to cut any holes or simply create a bioretention in this area. Okay. Yeah, the small area of your plaza actually sets up pretty well, that you don't have a lot of paved surfaces to deal with.
Yeah, I still have to make the corrections from the last exercise, so I hope I won't get any points off.
Oh, you won't. No, you don't have to change the baseline, the base map in order to do this exercise.
Okay, okay.
Okay. Yeah, but for this one, you do need to make it clear. Oh, now I see. The boundaries are over here. The boundary over here, meaning that most of this area is draining into this. Yeah, this seems like you'll be lacking some space. So you might need to at least make some changes. No, for your pavement boundary to be like this, then you have more areas in the middle here to treat your plaza runoff there. Yeah, seems like you have a pretty good handle on this one. Any additional questions here, Jacob?
No, that was great. Thank you.
All right, sounds great. Okay, then we can return to the main room. They may have already finished. Any other last minute questions from the group here? You feeling good? Cool. Okay, let's return to the main room.